Hey guys, this is video 12.6. We're going to talk about neutralization reactions here. This is to kind of set up our next topic, which is titrations. We're going to be doing a lab this week with. So we've kind of seen these neutralizations already. You had, when we were doing the conjugate pairs, one of your practice problems actually had a couple neutralization reactions in it. So if we go back and look at page 11 really quick. Okay, I know a lot of you I talked with about, but numbers 10 and 11, these were neutralization. And one thing that we saw that was different, when you look at these two reactions compared to every other one, there's no ions present. Okay, and the reason for that is because we have this sodium atom. Okay, sodium ion really when it's in solution, and what that's doing is it's balancing out any charge, so it's helping to neutralize the charges that might be there. Okay, so that's the one of the big parts about neutralization reactions is you're not going to see any ions. So it's going to make it a little bit more challenging if you're doing a conjugate pairs piece with it because it's neutral. Okay, neutralization reactions, like they say, they're neither acidic or basic. Okay, that means, and this is something big, something conceptual to remember, is that the hydrogen ion concentration equals the hydroxide ion concentration. So we talked in our last session of videos, right? If you have a greater hydrogen ion concentration, you have an acid. If you have a greater hydroxide, it's a base. When they're equal, that's neutral. And what is our pH for neutral? 7 would be the pH, okay? So these occur when an Arrhenius, and we're going to kind of review that here in just a second, an Arrhenius acid and an Arrhenius base, they react to form salt and, should be the other way around, to form water and a salt. Okay, so first off, a few different pieces in here that we need to take note of. Salt, what does salt mean? I'm going to kind of say it a few times throughout this video. You've got to know what this means. Any ionic compound. How do I know if it's ionic? Metal plus a nonmetal, or you have a polyatomic present, okay, in the compound, any polyatomic. Now, an Arrhenius acid, by definition, what does it produce in solution? It produces the hydrogen ion or hydronium ion. That's the way if you learned it and remember it by definition. But guys, remember, these are the same. Hydrogen, H+, is equal to the hydronium. So they mean the same thing. And an Arrhenius base, all right, produces hydroxide in solution. Okay, so that's kind of a big idea to remember here with it. So those are going to offset, which is where we get the water piece from within our reaction. Okay, and then the other ions that we have will form that ionic compound in terms of a salt. So an example, guys, of a neutralization reaction, antacids, right? The name says it all, anti-acids. So it's trying to neutralize the acids that are in your stomach. Okay, so they take a neutral salt to provide relief. General reaction, so you may have to predict products. At this point, we've done that a lot this year, but you know, it can't ever hurt to keep going over it because I know a lot of us struggle with it. So an acid plus a base produces that water, and salt, again, salt is just what? Ionic compound. So again, I'm writing it over and over to try to drive that home in your minds because a lot of us forget that. So this is what the mechanism could look like. So we've got hydrochloric acid, which is a strong acid, and we have sodium hydroxide, which is a strong base. You guys are actually going to be doing this reaction in our titration lab this week. And we're going to get water and sodium chloride as the salt. So notice here, we're still looking, okay, what pieces are going to be similar? So Cl is going to be that Cl. Well, what happened to it? We know that HCl is an acid because it's losing, when I go from one side to the other, it's losing that hydrogen. And we know OH signifies you have a base. Okay, remember water, HOH a lot of times. It helps us see that. It's gaining that hydrogen ion. So you can think of it, guys, by Arrhenius definition. Acids are H+ donors, bases are hydroxide donors by the Arrhenius definition. Okay. Either way, you've got to know which one's which. It should hopefully be a lot easier by now. Excuse me. So step 1, the H+ ion from the acid and the OH from the base, they're going to combine to form that water piece, which is going to help to make it neutral. And then the anion from the acid and the cation from the base combine to form the salt. And that's why you have that balance of charges, so you no longer have any ions in your reaction. So that's what makes them unique. Neutralization reactions are always double replacement reactions. So it's been a while since we talked about the types of reactions. Make sure you know those. Double replacement. 2 compounds on the left, 2 compounds on the right. Remember, guys, just like any compound, the positive and negative charges must be balanced. Use the crisscross method. We've been over this. If you're still struggling, call me over. We can do extra practice. Come see me after school. One thing, again, to know, I know a lot of us in our net ionic equations lab, as well as on our net ionic quiz, there are no longer any charges in a compound. Okay, so if you have formed a compound, there's no charges because they're balanced out. Okay, they're balanced. We use that crisscross method for it. So I want you guys to pause the video. You should be able to go through and predict the products for these 4 reactions, no problem. What should you always make sure you do with every single equation? It needs to be balanced. So pause the video, try predicting your products here. It should be pretty straightforward. All right, so I'm going to go through. One thing I can do first, all of these are going to have H2O because they're neutralization reactions. Okay, so I can kind of go through, fill those in. So then, figure out the other ones. So here, it's K and Br. So K has got a +1, Br has a -1. Crisscross those up. Okay, so KBr is what my salt would be in this case. Next one, if I remove the hydrogen here and the OH, because those have been taken out with water, so I've got Na, which is a 1+, C2H3O2, it's a polyatomic. It's a 1-, that's acetate. Crisscross those up. Na, C2H3O2. Remember, if there's one polyatomic, it doesn't have to have parentheses, so you could see it without it. Number 3, a little bit more challenging. Get rid of all of these. K is a 1+. PO4 is a 3-. This is the one where I think people may end up messing up because they're just going to say, oh, well, K only had a 1 subscript on the left. Guys, you've got to get that out of your mind. We have now moved past that. Just because it has a subscript on one side doesn't mean it's going to have the same subscript on the other. Here, when we do the crisscross method, we get K3PO4. So now, how do we account for this newly formed subscript of 3? We have to balance the equation. So we need a 3 here, and then we would have a 3 over there. That's where you take care of it. They don't automatically have the same subscripts. If you do that, balancing it is going to be a monster. Okay? So last one here. Okay, we've got Ca. Remember, the cation always goes first in the compounds as well. Nitrate has got a 1-. Crisscross those up. I get CaNO3 in parentheses with a 2 on the outside. I have to balance this as well, so there's a 2 there, and there's going to be a 2 there. Guys, if you can't do that, you need to do some extra practice. You need to come in and get the help that you need because you're going to have to do this on your Regents exam. It's not going away. You're going to have to do this on your Q3 test that's coming up as well. So the last thing we want to talk about is just kind of think, okay, well, what's happening? What's my product going to be with these different combinations? Okay, do you always get a completely neutral solution when you mix any acid and any base together? And the answer to that is no. So neutralization reactions, guys, they are strong acids with strong bases because the strength they're going to neutralize and cancel each other out. So strong acid and strong base, you would get a neutral, or should get a neutral solution in the end of pH of 7. But let's say if I have a strong acid with a weak base, which way do you think it's going to lean more? Yeah, it's going to be more acidic because you have more hydrogen ions than you do hydroxide. So if we were to draw a picture of this, you might have, like, with a strong acid and a strong base, you might have 3 hydrogen ions but only 1 hydroxide. So these would cancel out, but notice your net is still more acidic. So it would be less than 7. Okay? And then if we do the flip of a weak acid with a strong base, it's going to be more basic. Now that should be hopefully kind of straightforward and obvious to us. But again, Draw a picture. Strong base, you've got a lot of hydroxides floating around because it's completely ionized, where a weak acid, you only have it partially ionized, so it would only be able to cancel out, kind of one of those, so it's still going to be more basic. All right, so this is kind of the precursor to what we're going to do with the math in titrations in our next video.